Jai Hind all. Today the topic which I am going to discuss is operating systems, which comes under Unit 2 under the subject code KCA 101. So basically what is operating system? So it is a program that act as an intermediary between a user of a computer and the computer hardware. Or you could say it is a program which is sitting between the hardware and the user application. So what are the goals? Basically, it helps in executing the user programs and make solve their user problems easier. Moreover, and also it make the computer system convenient to use, and it use the computer hardware in an efficient manner. So we are having three basic goals available in operating system. First, it will solve your problems. Then secondly, it provide a convenient environment to the user, and the last one, it efficiently utilizes all the resources, or you could say it is a manager of all the resources of your system. So this is the view of operating system. At the lowest part, we are having computer hardware. That is, at the lowest level, we are having computer hardware. At the top, on the top of it, we are having operating system. Above it, we are having system and application programs. And we are having compiler, assemblers, text editor, database system, etc. as a system and application programs. And here, at the last level, we are having various users. And this diagram shows that if a user wants to interact with the computer hardware, then OS is the only way, or you could say OS is the in charge of your system. So by looking at the figure, OS can be defined in two manner. One is it is a resource allocator, and second it is a control program. What the resource allocator means? It manages all the resources and it decide between the conflicting requests for efficient and fair resource use. That is, all the resources which are associated with the system, it should be efficiently utilized, and also it should be done in a fair manner. That is, if we are having 5 processes in the system, then all these 5 processes, all these 5 processes, if they are contending for the same resource, then this resource would be allocated to all these processes. It is a control program. What it means? It means control the execution of a programs to prevent errors and improper use of the computer. That is, it will see if some error comes in a system, then it will look after all those errors. And if there is an illegal program trying to access your system resources, then OS will act accordingly. Types of operating system. We are we are going to discuss batch, multi-programming, time sharing, multiprocessor, and real-time operating system. What is batch OS? In the batch OS, the users of a batch OS do not interact with the computer directly. That is, we are having an operator available with us, and the user will submit its program to the operator, and the operator is responsible for executing the programs on the system. Each user prepares his job on an offline device, and these devices could be your punch cards, etc., and submit it to the computer operator. To speed up the processing, jobs with similar needs are batched together and run as a group. And this particular task is being done by the computer operator. So the programmers leave their programs with the operator, and the operator then sorts the program with similar requirement into batches and run those batches. And whatever be the output, whether that output is valid or invalid, it is being collected by the program, by the computer operator, and then the programmer collect those output from the operator. So the basic problem with the batch system is it is lacking the interaction between the user and the job, since the user is not directly interacting with the system. CPU is often idle. So you could say the resource utilization is minimum in this case, efficient utilization of resources. Why? Because the speed of the mechanical input output devices is generally slower than the CPU, and that is why CPU is sitting most of the time idle. And also it is difficult to provide the desired priority to a particular job. So this is the memory layout for a simple batch system. In the memory we are having OS, and the another area is reserved for user program area. Another type of OS are your mainframe systems. These computers are those elephant-sized machines which are found on major corporate data centers. A mainframe system has huge specification and is generally used for tons of input-output operations done together. It requires an OS that is different from what we see in day to day, that is your laptops and desktop, because in this case the processing requirement is very high, and moreover the memory requirement is also huge. So generally speaking, a mainframe system, it offers three kinds of services: batch, transaction processing, and time sharing. Batch system, this is a type of a system that processes routine jobs that do not need any user to be present, and examples are your reporting sales in a large store like Walmart. Then transaction processing, it deals with handling a large number of small requests, for example, airline or your railway reservation systems. Then time sharing. In this particular category, it allows the multiple remote users to access the system at the same time. For example, running queries on an extensive database. Another category is the multi-program system. In the multi-program systems, what is happening? We are keeping several jobs in the main memory at the same time, and the CPU is multiplexed among them. As we have seen in the case of the batch, we are having OS and then a batch and a batch of jobs. And once that batch got finished, then the operator submit the other batch in the system. Whereas in the case of the multi-program system, what is happening? Instead of a batch, we are having multiple jobs, and these jobs, they are having their own requirement. In the case of the batch, what is happening? When input output is happening in the system, then at that time, CPU is sitting idle. But in this case, if for example, if job 1 is executing and it has given certain input output activity, then in that case it will go for the input output, and CPU, it will select another job from this subset. So this is your multi-programmed systems. What are the OS features needed for the multi-programming? Input output routine supplied by the system, this is required. Memory management is required, CPU scheduling is required, and the allocation of devices is needed in the case of multi-programming system. Another important category of OS is time sharing. It is also known by the name interactive computing or multitasking system. You could say this is the logical extension of the multi-programming system. Here again, since it is the logical extension of multi-programming system, so CPU is multiplexed among several jobs. But what is extra happening in this case, that the user is interacting with the jobs also. So the CPU is allocated to a job only if the job is in memory. A job is swapped in and out of the memory to the disk, that is, we are having a concept of virtual memory. Online communication between the user and the system is provided. So when the OS finishes the execution of one command, it seeks the next control statement from the user's keyboard. That is, user interactivity is there. Online system must be available for users to access the data and code. What's the difference between multi-programming and time sharing? That is a multitasking systems. Multi-programming, it is needed for, basically it has been designed for efficient utilization of the resources. Single user cannot keep CPU and input device busy at all the time. So the multi-programming concept organizes the jobs, that is both code and data. So CPU always has one to execute. A subset of the total jobs in system is kept in the memory, as we have seen in the figure itself. One job selected and run via job scheduling, that is which job needs to be selected from that particular subset. So we are having a separate set of algorithm for this in OS, which is known by the name job scheduling algorithms. When it has to wait, that is for input output example, then OS switches to another job. Now, what is happening in the case of time sharing or multitasking, since it is a logical extension? So in this case, CPU switches jobs so frequently that users can interact with each job while it is running or creating the jobs. So interactive computing is there. What are the features in this case? Response time should be less than 1 second, but nowadays the requirement comes in nanosecond. Each user has at least one program executing in memory that is known by the name process in this case. If several jobs ready to run at the same time, then which job needs to be executed next? Which process needs to be executed next? It is being done with the help of CPU scheduling. If process don't fit in the memory, then we can go for the swapping, and this swapping store is your virtual memory. Virtual memory, it allows the execution of processes even the process is not completely present in the memory. Another important category is parallel systems. Multiprocessor system, with these are the systems in which we are having more than one CPU in close communication. And these are also known by the name tightly coupled system. Here the processors, they share same memory and the same system clock. So communication usually takes place through the shared memory. Why we go for the parallel systems? What are the advantages of this system? It increases the system throughput. It is quite economical, and it has increased the reliability of the system. If one of the processor fail, then its work is being taken by the rest of the processors, and that is why these systems are known by the name fail-soft system. And since the workload is being distributed among the remaining processors, that is why it supports the concept of graceful degradation. We are having two kinds of parallel system. One is symmetric multiprocessing, that is our SMP, and another one is our asymmetric multiprocessing. In the case of the symmetric multiprocessing, each processor runs the identical copy of the OS. So many processors can run at once without performance deterioration. We are having all the processors, they are having equal power. That is why we are saying that they are running the identical copy of the operating system. Most modern OS, they support this concept. Whereas in the case of the asymmetric multiprocessing, there is a concept of master and slave. What it says, each processor is assigned a specific task, and this particular thing, that which processor needs to perform what, it is being done with the help of a single processor, which is a master processor, and it allocate this work to the slave processor. So in the case of the asymmetric, we are having a master slave concept, whereas in the case of the symmetric multiprocessing, all the systems, they are having equal power. There is no master slave concept over there. More common in extremely large systems, we go for asymmetric multiprocessing. This is a simple figure which is showing the symmetric multiprocessing architecture. If you look at the figure, we are having 3 CPUs, CPU 0, 1 and 2. Each is having its own set of registers and cache. That is how you identify that this is CPU 0 along with these set of registers, and this is the cache associated with CPU 0. Similarly with CPU 1, we are having its own register set, its own local cache system. Similarly for CPU 2 also we are having its own registers and local cache system, but they are connected on the same system bus and they are sharing the same system memory. Another important category is your real-time systems, as the name is having time. So it signifies that basically here the time is the major playing feature in OS. often used as a control device in a dedicated application. For example, your controlling scientific experiments, medical imaging systems, industrial control system, and some display systems. Here we are having a well-defined fixed time constraint. That is, the particular task should finish in that particular time, in that particular deadline. If that deadline surpasses, then the system may fail. So such systems are your real-time systems. Now the real-time systems, they can be hard or they can be soft real-time system. These are the two categories of the real-time systems. So what is hard? It says that the secondary storage is limited or absent in the case of hard real-time system, and the data is stored in short-term memory or your read-only memory. And the conflict with time sharing system not supported by general purpose operating systems. We are having well-designed specifically designed OS for this purpose. For example, your nuclear reactor systems where there is a coolant and there is a system which is monitoring the cooling of your of that particular nuclear reactor, then the deadline is very important in this case. Soft real-time system, limited utility in industrial control of robotics, useful in applications. For example, your multimedia, VR related applications, they are having soft real-time systems. They come under the category of soft real-time systems. Next important concept in OS is is your system components. These are the basic system components which you can find in any OS, maybe your Android, maybe your Linux-based systems or your Windows-based system, etc. So what are these components? Process management, main memory management, file, input, output, secondary, networking, protection, command interpreter. If you look at all these components, there is a one component which is particularly looking after an important resource of a system. For example, in the case of the process management system, it is something, this module is associated with the proper functioning of the processor. Similarly, in the case of the main memory management component or module, this particular module is responsible for looking after the proper functioning of your RAM. Similar, file system should work efficiently and it should be, the files should be properly organized. So file management module is responsible for this activity. Similarly, we are having other components also. Let's have a look at all these components one by one. First one is your process management. So we have already seen what is a process. It is a program in execution. It is just a code which you write, and once you execute it, then it is more than that. It includes various things, for example, CPU time, memory, files, input, output, devices, etc. They also got associated with a program. So the OS is responsible for the following activities in connection with the process management: how to create a process and how to delete a process. Then sometimes we need to suspend a process, and once the process is suspended, we have to resume it. Other things are also there, for example, your process synchronization concept and process communication concept. OS also responsible to look after that the processes, they should execute in an orderly fashion. Moreover, the resource, if they are sharing some resources, then that resource should be shared in a proper way. Similarly, if two or more processes they are communicating, then how the communication can be done, how the communication channel can be established between the two processes, it is also being looked after by your operating process management component. Another important component is your main memory. So memory, we are aware that memory, it is a large array of words or bytes, each with its own address. So it is you could say it is a repository of quickly accessible data shared by both in CPU and input devices. You are aware that main memory, it is a volatile storage device, and it loses its content in the case of the system failure. So what are the roles of the OS in respect to your main memory? It keep the track which parts of the memory are currently being used by which process, um, and how much. It also decide which process to load when the memory space becomes available. For example, some process terminate, then its space got available, and if we are having 4 or 5 processes waiting to be waiting to get the space allocated, then in that case OS has to decide that which particular process needs to be allocated memory first, and this module is looking after this particular concept. Allocate and deallocate memory whenever it is required. Another important component is file management. We are aware that a file, it is a collection of related information defined by its creator. Commonly, files represent programs and data. So the OS is, what are the responsibilities of OS in as a file management component? Here, how we create a file and delete, then directory creation and deletion, how we manipulate the files and directories, how the files they are mapped onto the secondary storage. That is, once you give a save command, then which particular where your files are being stored on the secondary, that is a hard drive. File backup on stable storage media, that is, if you are running the system backup, you are taking a system backup, then how the this to be taken on the tertiary media. Input output system management. In this case, the OS is responsible for buffer caching system, how the caching how the cache system to be implemented, how the buffers to be allocated, then the general device driver interface, drivers for specific hardware devices, they are also being looked after by this particular component. Next component is a secondary storage management. Since main memory is volatile and too small to accommodate all the data and programs permanently, so the system it need another storage device, and that is a secondary storage device, and it is non-volatile in nature. Most modern OS use disk as the principal online storage medium for both programs and data. What are the responsibilities of OS in connection with the disk management? Free space management, storage allocation, and disk scheduling. That is, in the disk, in your hard drive where the free space is available, the OS maintains the list of all these free locations. If we are having multiple files to be saved or multiple files waiting to be allocated space on the hard drive, then how the allocation is being done, it is also looked after by this module. And disk scheduling, it is another set of scheduling algorithms which are being implemented under secondary storage management module. Another important component is your networking and your all the distributed systems. They are having this networking OS component. A distributed system, it is a collection of processors that do not share memory or a clock. So each processor has its own local memory, and these processors in the system, they are being connected through a communication network. Communication is being happening with the help of a predefined set of network protocols, for example TCP, etc. A distributed system, it provides the user access to various systems and resources. Access to the shared resources, why we go for the distributed computing, for the computation speed up, increased data availability and enhanced reliability. Another important component is a protection system. So protection here refers to a mechanism for controlling access by programs, process or users to both system and user resources. In OS, basically we deal with the protection part and not the security part. Here the protection means that if two processes they are running in the system, then in that case both the processes, they should operate in their particular domain. So the protection module, what it does, it distinguishes between the authorized and unauthorized usage, which is being done by different processes. If some process is using some resource in an unauthorized fashion, then it might get blocked by the OS. Specify the controls to be imposed, and it provide a means of enforcement. Here we define the rule, and here we define the mechanism, that is how we can implement the rule, what kind of data structures we can use to implement these rules. Another important component is the command interpreter system, and this is a very important component in your OS. Many commands, they are being given to the OS by control statements, and these commands, they may pertain to process creation and management. We need them for input output handling, for secondary storage management, memory management, file system, protection, networking. That is all those components which we have seen earlier. Their services, if we want to use their services, then it can be done only with the help of certain commands. And the user can give these commands with the help of command interpreter system. In the case of Unix, this command interpreter system has given a specific name, that is shell over there. So basically, whatever you are giving a command to a system, it is being taken by this shell. It interprets this command, that is, it will check its validity, etc., whether that command has been written correctly, what are its arguments, are the arguments valid or invalid. All the interpretation is being done by this particular shell. And once it checks all the that the command is valid, argument is right, then it will send this command to the kernel for the execution. So command interpreter system is very important. This is all about today's lecture. So in this lecture, what we have seen OS, its definition, then what are the various categories of the OS, for example, your multi-programming, multitasking systems, your parallel systems, real-time systems, and then we had covered the topic related to various OS components. This is all about for today. Thank you.